right, y'all need to see me. Okay, so I'm going to address what are elements. Very short video, straight to the point. All right, so as soon as I get this, all right, let me share my screen. Whoa. Where's my mouse? I hate when I do that. All right, so hold on 1 second. Oh boy. All right. Oh, mama. All right, I had to get my mouse. I hate using these Macs without a mouse. Microsoft or Windows are a little better to use without a mouse. All right. See. All right. I don't think you guys can see my screen. Yes, you can. All right. So let's get it. What are elements? First, what is matter? Matter is anything that has mass, okay, and occupies space. Anything that has mass and occupies space. Why isn't my screen? Okay. Matter is made up of either pure substances or mixtures of pure substances, okay? Substances themselves are made up of either elements or compounds, right? An atom is the smallest constituent unit of ordinary matter that has or that constitutes a chemical element. An atom is the smallest constituent unit of ordinary matter that constitutes a chemical element. Okay, if you break an atom down any further, it will no longer be an element. Every solid, liquid, gas, and plasma is composed of neutral or ionized atoms. Okay, ionized just means an atom with a charge, either positive or negative. Neutral is no charge. Okay, so most elements are neutral naturally. Every atom, unless you're dealing with ionic bonding where they start to share or take each other electrons. We'll deal with that later. Every atom is composed of a nucleus and one or more electrons bound to the nucleus. So every atom is composed of a nucleus and one or more electrons bound to the nucleus. Hydrogen has a nucleus, and that nucleus contains only one proton and there is one electron. There's no neutrons in hydrogen, okay, in the nucleus of a hydrogen atom. The nucleus is made of one or more protons and a number of neutrons. Protons and neutrons are called nucleons. The protons have a positive electric charge, whereas the electrons have a negative electric charge. The neutrons have no electric charge. They're neutral. The electrons of an atom are attracted to the protons in an atomic nucleus by the electromagnetic force. The protons and neutrons in the nucleus are attracted to each other by the nuclear force. This force is usually stronger than the electromagnetic force that repels the positively charged protons from one another. Okay, so the protons do not repel against each other because of the strong nuclear force, or they call nuclear glue. A chemical element, what is that? Is a species of atom having the same number of protons in their atomic nuclei, that is the same atomic number, or Z. All right, make sure we understand everything I just read. Okay, so, all right. here we go. When you're dealing with the element chart or the periodic table, you're gonna start seeing things like this. Okay, so you have symbols on the element chart, which tell you which atom you're dealing with. So the X right here represents the element. It could be hydrogen, nitrogen, anything right here. That's the element. On top is the mass number. That's the weight of the atom. And Z represents the atomic number. What type of element is it? Okay, so the mass number is composed of protons and neutrons together. Okay, so if you have 5 protons and 5 neutrons, that is 10. That would be the atomic mass or the weight of the atom. The atomic number is the element, and the protons tell you what element the atom is. So the atomic number only deals with protons. For example, the atomic number of oxygen is 8. So the element oxygen consists of all atoms which have 8 protons. And by the way, when you're dealing with atoms, whatever number count the proton is, it's safe to assume that that is the electron count. If the electron count is different than the proton count, then you have an ionized atom, meaning that it is charged. It's either positive or negative. Clearly, if you have less electrons, that means you have more protons. Protons give a positive charge. That means the atom is a positive charge. It's a positive charge atom. If you have more electrons, then it's going to have a negative charge. Real simple. Okay, so here's a little example of how it will look. We have helium, which is 2. Okay, that represents the element. 4 represents the mass, the weight. Okay, so it's the protons and the neutrons together. Boron, 5, that's the element. 6, 7, 8, 9, 10, and it goes up and down as you count. Okay, so let's read that one more time. The atomic number of oxygen is 8. So the element oxygen consists of all atoms which have 8 protons. All right. If there were 9 protons, then you would have fluorine. You have a whole different element. Chemical elements constitute all of the ordinary matter of the universe. One more time, slowly. Chemical elements constitute all of the ordinary matter of the universe. This is how they know that there are no other elements out there. We have what we have on the periodic table. It's filled. Okay? All of the universe. However, astronomical observations suggest that ordinary observable matter makes up only 15% of the matter in the universe. The remainder is dark matter. The composition of this is unknown, but it is not composed of chemical elements. Okay? Dark matter is not composed of chemical elements. So it will not add to the table, to the chart. Okay, so the term element is used for atoms with a given number of protons. Okay, the term element is used for atoms with a given number of protons, regardless of whether or not they are ionized or chemically bonded, e.g., hydrogen and water, as well as for a pure chemical substance consisting of a single element, e.g., hydrogen gas. So here we go. Mass number, number of protons and neutrons in an atom. Mass number or weight, okay? The atomic mass is the weight of the atom. That represents A, okay? A represents the mass number, protons, neutrons together. Z represents the atomic number of protons in the atom. Protons only, because protons determines the element. Atomic symbol tell you what atom you're dealing with. Abbreviation used to represent atom and chemical formulas. You know, something like the stock market, like the tickers. All right, so we have a carbon atom. So we have 6 protons, 6 neutrons, 6 electrons. You do not add all 3 and get 18. That's not how it works. Electrons, the weight of an electron does not affect the atom. It's too light. You would need too many electrons to affect the weight of an atom. So we don't even count the electrons. You would need somewhere near 2,000 electrons in a given atom for the weight to be affected. Okay, there's not that many electrons in any given atom. So we don't even count the electrons. You only count the protons and neutrons, and that's how you come up with 12. All right. Then the 6 is the number of protons. 6 represent which atom or what atom you are dealing with. When you see the number 6 as the element, you're dealing with carbon. And if you got 7, it's a whole different element. You're dealing with nitrogen, oxygen, fluorine, neon. Okay. So carbon has 6 protons, okay, the atomic number, and 12 nucleons, atomic mass. Don't forget, nucleons is nothing but neutrons and protons together in the nucleus. In a neutral atom, the protons, neutrons, and electrons are the same number. See, carbon has 6 protons, 6 neutrons, and 6 electrons. If this atom adds an additional proton, then the element type changes to nitrogen, which has 7 protons. Okay, nitrogen 7, there you go. Elements are identified by their proton number count. So nitrogen 7 protons, carbon 6 protons. If this atom adds an additional neutron, then the element type stays the same. It's still C6, okay? Because we didn't add a new or another proton, we just added a neutron. However, the atomic mass or the weight changes and it becomes an isotope of carbon. So it becomes a different variation of carbon. The atomic number remains at 6, but the atomic mass changes to 7. And now we have carbon 13, 6. Remember, 13 represents the number of the total numbers of protons and neutrons. So if you have an additional neutron, now you have 7 neutrons with that one, with the 6 protons, all right? So if you add an extra neutron in the atom of carbon, you get 7 neutrons and you still have your 6 protons. 7 plus 6 is 13. So that becomes a new weight of the atom, okay? But you still have your 6 protons, so you still are dealing with carbon. Isotopes are variants of a particular chemical element which differ in neutron number and consequently in nucleon number. All isotopes of a given element have the same number of protons, but different number of neutrons in each atom. Okay, isotopes are the same element type, just a different set of numbers of neutrons in the nucleus. That's all. All right, so I want to make this short as possible so you can watch it over and over and over. Any questions, just comment, and if need be, I'll do a second video to further explain, further clarify any concerns. But I think this video was simple. All right, peace.